Part 2, here we go. Our next problem.
Yeah, we're recording for like 20 minutes.
And before we leave this side of the board, I just want to make a comment. Either write it in your brain and keep it, or write it on your paper and study it. I just want you to know that friction always decreases kinetic energy. It can never add to it. Friction always decreases kinetic energy. We saw it here, and that is always going to be the case. Friction always decreases kinetic energy. See if I can fit a problem in here. Draw a book on a table. The old book on the table. It's a physics book, of course. 2.15 kilograms. I don't have to convert, I'm in kilograms, so I'm happy. I'm going to shove that book across the table, and when I shove it, it's going to have a velocity, and it's going to be 0.95 meters per second. And the kinetic, the coefficient of friction between the book and the table is coefficient of kinetic friction, it's moving, is 0.34. So get down all the data. And you can add the question, how far before it stops? How far is it going to go? If I know what my velocity is initially when I push it, and I know the kinetic coefficient of friction and the mass, I should be able to figure out how far before it stops. All right, right away when I see the question, how far, which of these formulas has anything to do about how far? Do you see any of them? That might help. Looking there, we're looking for a part that has how far.
No.
Well, what would it look like? What variable is going to take the place of how far normally?
X.
All right, do you see an X up there?
Yeah.
Where is it?
Work.
All right, so that points me to the place to start, because nothing else has an X in it. So I'm going to run out of room, but you won't. So the work equals force parallel times X. What is doing the work in this one? All the work is kinetic. And what's the force that's being applied once I pushed it and that force is already passed? The only force that's left is friction. So the force of friction is going to be written on the next line. So I'm going to change kinetic to 1/2 mv squared, and I'm going to change force of friction to this one, mk mg x. All right, I can cross out mass. If you forget to do that, your problem will work out as well. If you put the mass in both sides, you'll get the right answer. This is a little less work. If you notice, it's in both terms. We can cross it out. So I'm left with 1/2 v squared mk g and x. We know everything but x. So fill it in, put in the velocity, it's known. mk, it's known. G, we know. And solve for x. Can you see that? I smushed it on.
I'm gonna
Alright.
zoom in action real quick.
There you go, thank you.
Write that down.
We're right down to here, and we're filling in the values and solving
Oh, crap.
for,
Oh.
this time it says how far, so we're solving for x. Can I peek at your answer when you get one? Anyone got it? That's what I got. I did it. Got one? Yeah, meters.
Yeah.
Do we
Got
convert
it.
2.15?
It's already in kilograms.
Yeah, make sure your square velocity.
Or it's 9.8?
Your last
The mass
step
is
is
crossed
not a
out.
square root though.
Oh, mass
It's
per
just a
cylinder,
regular
GHG.
old
Gravity.
You're gonna
That's what
square V, you're gonna square 0.95, multiply it by 1/2, and divide by 0.34 times 9.8. And when you do all that, some people were getting, and I think it was more than one, so I'm confident, is 0.14. That's
What I got. Yep.
Alright, that's how far it'll go. 5 minutes, no way. Alright, you spend too much time messing around at the beginning of class. Alright, as I said, I promised you 3 problems. So let me finish the next one. It looks like we'll be ready to test on Tuesday. How's Tuesday for testing? We're at the end almost. Any other
Tuesday seems like a good idea then.
Any other big tests or projects due on Tuesday?
No, I don't think so. I can't even think right now.
Okay. All right, last example in your training. Let's have a hill of some sort of slope, and we're gonna have a 2.2 kilogram box that's gonna slide down, and at the bottom, its speed is 3.2 meters a second. And I want you to find, is that all I need to tell you? I think so. Oh yeah, the height of the hill, of course. 1.2, so sketch that. The question is find the force of friction that works in this problem. Any ideas before I train you? So it's starting at the top, and it comes down to the bottom. We know the height, we know the mass, we know the velocity at the bottom. How could I find the force of friction on this one? Any thoughts? Will you need an MGH? Will you need a 1/2 mv squared? The answer is yes. What happens is, remember, when we start at the top, we have all kinetic, no kinetic, all potential, and we get to the bottom, it switches places. However, what happens if I do an MGH at the top, and I get a number, and I come down at the bottom, and I get 1/2 mv squared, and they're not equal? I said that everything from the top, it's all potential at the top, all kinetic at the bottom, but what if those numbers aren't equal? What has happened in between? Friction. So do you see the strategy?
Oh, so you subtract it.
Right,
Okay.
so what you're gonna do is find the potential at the top minus the kinetic at the bottom, because that will be the work of friction, the force of friction's work. So I'll say the work of friction. Work of friction. So MGH at the top minus 1/2 mv squared at the bottom will give you the work of friction. Make sense?
Yeah.
All right. So if they were the same, that means we would be on a frictionless plane, which is quite unusual in this world. All right. MGH at the top. We can't cross out the mass this time. It would have to be on this side as well. It's not, so we have to.
Velocity.
Mass, velocity, 3.2, don't forget to square it, equals the work of friction. When you tap that all out, I use sig figs and I got like 26 minus 11. Anyone get something like that?
That's what I got.
15 joules then. All right. We have a worksheet that exercises these things. Let's see if you can just start the first one, maybe with the drawing. And we'll be working on this in class. We're only trained to do 1 through 7, but it is not assignment. We'll just do it in class tomorrow. Bring this paper, and we'll show our friends this paper. Is it on the video? Is it on the view?
It's a little blurry. There you go, guys.
I need to turn it over as well.
Hopefully they copy that down.
Yeah, they can work. What we're doing in class today, Video Land, is just drawing the first one and thinking about how we're going to start it tomorrow. And we're only trained to go 1 through 7. So here's the 3 on the back.
7. There you go. There's 8, and then 9.
No, we
Oh,
don't
it's
need.
10.
Just stop at 7.
Okay.
7's good.
7. Don't worry about 8, 9, and 10.
No, not for now. We're not ready for those.
You're not ready.
All right. So just work with number 1 until the bell rings. This is not an assignment. We will do it
Oh,
in
sweet.
class tomorrow.
Awesome.
We will work these problems, and I have one more thing to teach. You'll finish those 3, and we'll be done the whole mod tomorrow. Then we can review on Monday and test on Tuesday. So that's the plan. So you are now a man with a plan.